Hi guys, let's look into the real basic laws of stoichiometry. These are the laws from which mole concept actually developed. Understand these laws might look very mundane right now. ரொம்ப ஈஸியா இருக்கும் உங்களுக்கு பார்க்கிறதுக்கு. But when they were first discovered, people didn't know that this is how compounds existed and many of them hold true till today. Rarely you get a question in NEET based on this. JEE mains-ல வந்து நிறைய வரும். NEET-ல வந்து rarely you get, even if it is rare, if you get it in your year, it is still important. So let's revise them. The first one, law of conservation of mass, is extremely simple. Anton Lavoisier has done it. In all physical and chemical changes, there is no change in mass. The physics law of conservation of mass, meaning நீங்க x grams of reactant எடுத்தீங்கன்னா x grams of product தான் கிடைக்கணும் உங்களுக்கு. Combined reactant and combined product. For example, if you were to take, let's say, let's go to a reaction that we already know. N2 plus 3H2 gives you 2NH3. Let's say total, I don't care about how much. Let's even put this way, X, Y and Z. Let's even make it complicated. Let's say that one of them is limiting reagent. I don't know which one, doesn't really matter. Limiting reagent enna paathirukom, one that gets used up and other one is left over. Okay, let's say for example ammonia is the limiting reagent, nitrogen is the limiting reagent, hydrogen is the excess reagent. So all of nitrogen is used up, some of hydrogen is left over, corresponding amount of ammonia is formed. Does not really matter if there is a limiting reagent or not. All you need to know is x plus y should be equal to Z if there is no limiting reagent. If there is limiting reagent, it will be x plus leftover, meaning no loss in mass. For example, இதில் எடுத்துக்கலாம், x வந்து limiting reagent, அப்போ y வந்து எவ்வளோ யூஸ் ஆகுது அப்படின்னு பார்த்தா, let's say a is used up, அப்போ leftover என்ன, y minus a, the a you would add it here. Simple equation எடுத்துக்கிட்டால் limiting reagent பார்க்கலன்னா நீங்கள் total என்ன reactant எடுக்கலாம் அதோட weight total productsல இருக்கணும், because you cannot lose anything, the mass cannot be lost. This is too simple of a law, nevertheless important. Law of definite proportion. This is a little tricky. This is an old law, doesn't hold true for all compounds. Joseph Proust did it based on the examples that he saw. A given compound always contains exactly same proportion of elements by weight. இதில் key என்ன அப்படின்னா, a given compound, அந்த compound நான் கொடுத்துட்டா it is always true. But if I am comparing different compounds, it doesn't have to hold true. A given compound, let's say water. What do we know as water? I know it as ice, liquid water and steam. Doesn't really matter how I have. The weight of hydrogen in 100 grams of ice is same as weight of hydrogen in 100 grams of water, as it is same as in 100 grams of steam. Doesn't really matter what phase you have. Similarly, for example, let's say we have a compound like, let's even say something like natural drug, okay, curcumin. You have it in your turmeric powder. Let's say we talk about curcumin. This is the one that gives the yellow color. Now, if there are two sources, one is natural, one is artificial, synthetic. If you take natural, the weight of the atoms ratio in curcumin would be exactly same as what you would synthesize in your lab. You cannot be different. And another way of looking at it is, in our normal mole concept problems, you don't really care about what's the source of the compound to calculate molecular mass. Mass கொடுத்துட்டா நீங்கள் molar mass யூஸ் பண்ணி directly moles calculate பண்ணுறீங்க. We don't worry about the source. Why? Source doesn't matter. Law of definite proportion says doesn't matter where it comes from, the given compound will have the same molecular formula, so hence the same mole ratio of the different compounds or different atoms. Let's say this one, or glucose, doesn't matter where you get the glucose from, this is the ratio, mole ratio. Mole ratio is same, then the mass ratio is same. This is law of definite proportion. Understand, this is not okay with compounds that can have variable valency. Remember, we have seen this before. This is not stoichiometric, so you cannot have it. non-stoichiometric compounds, and atoms with variable valency. Even this example we saw why this happens. We have Fe3 and Fe2+. So for example, let's take nitrogen, NO, NO2, N2O5. There is no way you can say this law is holding good in this circumstance, because the proportion of elements by weight, this is 14:16, whereas here it is 14:28. Here it is 28:80. So they are different. So law of definite proportion will not hold good when there is variable valency or when there is non-stoichiometric. But otherwise, if you take the same compound, regardless of the source or regardless of the phase, this law holds good. The next is most important. This can come as numerical also. Law of multiple proportion. What we saw before was constant proportion, but multiple proportion is true. Two elements form more than one compound. For example, I have shown you oxides of nitrogen. They are forming more than one compound. The ratio of the masses of second element, let's say here our oxygen, okay, here second element is our oxygen, which combine with fixed mass of the first element, nitrogen, fixed mass, okay, let's say x grams, will always be ratio of small whole numbers. Two elements form more than one compound. The first element is nitrogen, so they are telling you the fixed mass of first element. So nitrogen on the fixed mass எடுத்தீங்கன்னா, the other one will always be a ratio of small whole numbers. For example, let's take here. This is my first element 14, second element 16. So 14:16, one compound. When I go to this, 16:32. So the ratio of the masses of second element, what is the ratio of mass of second element here? 16:32 or 1:2. Let's take these two. With 14, 16 combines, with 28, 16 combines, or with 14, 8 combines. So the ratio of NO and N2O oxygen is, I have 16:8 or 2:1. So still ratio of small whole numbers. Okay, this is simple. Now let's go to something like this, which is a little different. N2O5. I'm going to compare my first one and fifth one. What do you have? My ratio of first element or the fixed mass of first element. So 14 of nitrogen combines with 16 of in the first case. In the fifth case, 28 combines with 80 or 14 combines with 40. Correct? Okay. I have made my mass fixed of my first element. Now what is the ratio of mass of second element, oxygen? 16:40. Can we write it as 4:10 or 2:5? Now again, this is the ratio of small whole numbers. Understand, do not try to bring it as 1:something. That will not be a whole number, and that is not the law proposed by Dalton. It is basically, it has to be some whole number. Let me even do an example for you. Let's take something complicated. Fe3O4, Fe2O3. Okay, completely different. Now what we can do, can we show this obeys law of multiple proportion? Can we write it as FeO 4/3? Basically mole ratio 3:4 or 1:4/3. FeO 3/2. So there is one Fe here, one Fe here. So they have fixed mass of the first element. 1 mole means fixed mass of the first element. Now what is the ratio of the mass of second element? So oxygen mole ratio is 4/3, 3/2, correct? First one, second one 4/3. What's the mass ratio? 4/3, 3/2 again, because moles to mass is multiplying by molar mass. Molar mass is same for oxygen, it will get cancelled out. Now if you see, you can cross multiply. The next law we are going to see is law of reciprocal proportion. This is again logic. If two elements combine separately with the same weight of a third element, okay, so let's say for example, I have A combining with B and C combining with B. So they are combining with the same weight of the third element. The ratio of the masses in which they do so are either same or simple multiple of the mass ratio in which they combine. For example, what it means is ரெண்டுமே வந்து ஏவும் சரி சியும் சரி ஒரே கிராம் ஆஃப் பியோட தான் ரியாக்ட் ஆகுது அப்படின்னா then their mass ratio, okay, the ratio of mass in which they do so, x is to z, will be same or simple multiple of the mass ratio in which they combine. அது ரெண்டும் ரியாக்ட் ஆகும்போது இருக்கிற மாஸ் ரேஷியோவாக இருக்கணும், இல்லை அதோட simple multiple இருக்கணும். So the statements you are not expected to write down, so you don't have to word it properly, just understand it this way. So I have hydrogen here. In H2S, 2 grams hydrogen joins with 32 grams sulfur. In water, 2 grams hydrogen combines with 16 grams oxygen. So what is the mass ratio in which sulfur and oxygen combine? 32 is to 32. Okay, here it is 2 is to 32, here it is 2 is to 16. So they will combine in the ratio 32 is to 16, either the same or simple multiple. So a multiple of this would be 32 is to 32. This is all based on logic. Understand, this actually reverse synthesized laws. They looked at the example and then they got it. This doesn't hold true for many of the compounds later because they have variable valency. But at this point, they may give you an example and ask you whether it obeys or not. So how do you find an answer? Very simple. This is the reciprocal law. In the module you should be able to say 3 things combining. That's all. The next is law of gaseous volume, Gay-Lussac law. The ratio between volume of reactant gases and gaseous products can be expressed in simple whole numbers. The reason is, take a balanced equation. Okay, I want to go to Avogadro's law and then come back to this. Equal volume of all gases at same temperature and pressure have equal number of molecules. This we have seen it many times, and we also know at STP 1 mole of any gas occupies 22.4 liters, meaning identity of the gas is not important. Ella gasame ore marada irukum, moles and volume conversion. Now going to gaseous volume law, look at this. This is the balanced chemical equation. So what does it tell you? 2 is to 1. What ratio is it? Mole ratio. 2 is to 1 gives you 2. Because we know moles and volume can be equated, this is also volume ratio. So what would the volume of this be? Let's say even STP, 22.4 times 2 liters. 22.4 times 1 liter. And a mole on the 22.4 react agum. Sorry, occupy pannum. This is 22.4 times 2, which is again 2 is to 1 and 2. Now, the ratio between volume of the gaseous reactant and the gaseous product can be expressed in simple whole numbers because your balanced equation is a ratio of simple whole numbers. That's all. It's just the way it is worded. Alright, now let's look into a couple of questions from our worksheet that we have done. Mass of nitrogen per gram of hydrogen in compound hydrazine. So, hydrazine is NH2. NH2 we have also seen it in coordination chemistry. It's a bidentate ligand, but denticity is only 1 because 3-member ring. Okay. It's exactly 1/2 times the mass of nitrogen in compound ammonia. So look at it. They are talking about 2 different compounds and they are having different ratio. So this is not a reaction. So there is no conservation of mass. This fact illustrates multiple valency of nitrogen, which is true. Multiple valency of nitrogen is correct, but at the same time, this is not telling you about the multiple valency, it tells you about the ratio. It's exactly 1.5 times. So we can say 1 is to 1.5 or 2 is to 3. So that is law of multiple proportion. This is correct, but not the one that is illustrating here. So it is correct statement, but wrong answer. This is the correct statement and the correct answer. Law of definite proportion is impossible because The ratio is different. We have to talk about the same molecule. Carbon dioxide contains 27.727 grams of carbon. Disulfide contains this. The data is agreement with. Okay. Let's do this way. See, now they are talking about three different compounds. Right away, you can say the answer is law of reciprocal proportion. But let's see how it works. 27.7 grams of carbon dioxide. So I have 27%. That tells you oxygen is 73%. So if I take 100 grams, so this is the gram ratio. On the other side, I have 16 grams, so this is 84 grams. 16 grams combined with 84 grams, I'm going to make it equal now. How about 27 grams? 16 grams combined with 84, 27 will combine with, so we can say 27 by 16 times 84. Okay, now you look at the ratio of these two. So what would this be? So you can take it roughly as 80 means roughly 5. This is going to be 5 point something, roughly 5. So now we are going to have here roughly 100, 135. 5 point something means roughly 140 something. Now look at the ratio of these two, 2:1. Hence, it's actually telling you it's a law of reciprocal proportion. Just like the example of water and H2S that we have seen. Okay, we don't, but my advice is do not calculate anything. Three different compounds cannot be conservation of mass because it's not a reaction. Law of definite proportion, that is not true because we are not talking about same compound. Law of multiple proportion, we are not talking about same elements in two different compounds. இதில் என்ன இருக்குன்னா law of multiple proportionல A and B in different ratios. Okay, it could be ABX, ABY, something like that. Reciprocal proportion is three different compounds. That's how you identify them. But don't waste time calculating it. One part of an element A combines with two parts of element B. One part combines with two parts. 6 part of element C combines with 4 parts of element B, or C3, B2. If A and C combine together, the ratio of the weights will be governed by obviously law of reciprocal proportion. It will be in the ratio accordingly. If you are given masses, you can even calculate it. Conservation of mass has to be given reaction. Multiple proportion means between two different atoms forming different compounds. Law of definite proportion, impossible, same compound. N gram of substance X reacts with M grams of substance Y to form P grams of substance R and Q grams of substance S. So, law of conservation of mass tells you N plus M equals P plus Q. Grams of reactant equals grams of product. So, N plus M equals P plus Q. Understand, this can be modified. N minus P can be equal to Q minus M, like that. So, be very careful. Alright. Zinc sulfate contains 22.64% zinc and so much of water. So, when you take 100 grams of zinc sulfate, some hydrate, we don't know, let's just put it this way. The amount of zinc is 22.64 grams. Amount of water is 43.9 grams. 100 minus this plus this would be amount of sulfate, by the way. If the law of constant proportion is true, meaning இந்த காம்பவுண்டை எப்படி சிந்தசைஸ் பண்ணாலும் சரி, எவ்வளோ எடுத்தாலும் சரி, எந்த ஃபேஸில் எடுத்தாலும் சரி, இதே ரேஷியோவில் தான் இருக்கும். It's true, the weight of zinc required to produce 20 grams of crystal will be. Okay, so now 100 grams எடுத்தா zinc வந்து 22.64. அப்போ 20 grams of the crystal தான் நம்மளுக்கு வேணும்னா 100 grams-க்கு எவ்வளோனா 20 grams-க்கு எவ்வளோ வரும்? 1 by 5. So, 22.64, if you want it, we can write it this way, times 20 by 100, 1 by 5. Okay, so 1 by 5 is 4.53 grams. Law of definite proportion is not applicable to nitrogen oxides. Different types of nitrogen oxide, because nitrogen has variable valency. If it has variable valency, it has different equivalent weight. So I explained it to you in when I explaining law of definite proportion. Variable valency, definite proportion will not hold true. Law of variable proportion will hold true, but law of definite proportion will not hold true because different valency. Right away we know different valency means equivalent weight is molecular weight by n factor. N factor in our case is valency. If the valency changes, equivalent weight changes. Hence, that is the answer. What quantity of ammonium sulfate is necessary for production of ammonia? Okay. See, I put the equation here, but you don't need to worry about knowing the equation. You just need to know the formula. Ammonium sulfate, SO4 2 minus, so this is this. They are telling you this gives ammonia. How many ammonia can it give? Obviously 2. I don't care about what is formed later. And I know that it can react with HCl to give ammonium chloride. So I need 2 of this. What quantity of ammonium sulfate is required for production of NH3 gas sufficient to neutralize 292 grams of HCl? So this is 292 grams. Okay, now we can go here. I have 292 grams. I can convert this to moles. Moles of this to moles of this, moles of this to moles of this to grams of this. Okay, now I don't have to convert to moles. Now look at the equation, combined equation. 1 mole ammonium sulfate gives 2 ammonia. 2 ammonia reacts with 2 HCl. So 1 mole ammonium sulfate is equivalent to 2 HCl. So எனக்கு moles of HCl தெரிஞ்சதுனா moles of ammonium sulfate தெரிஞ்சதுனா என்னோட mass of ammonium sulfate calculate பண்ண முடியும். Okay, so now we can write it this way. NH4 twice SO4. 1 mole is equivalent to 2 HCl. Okay, now we know 292 grams is the what is the amount. Now look at it this way. What is the molecular mass of HCl? 36.5. Upper 2 HCl is 73. 2 moles HCl is equivalent to 1 mole NH4 twice SO4. What is the molecular mass of this? 132. So 73 is equivalent to 132. 292 is equivalent to what? So 72 times 4 is this. So what is the times 4 of this? About 528 grams. This is logic. One mole concept vadiya polam. I know the moles of this to moles of this, which means the same as this one, and then moles of this to grams of this. So we have done this many times. Given to moles of A to moles of B to what is asked. We can do that, or we can just do simple logic. Okay. 100 tons of Fe2O3 containing 20 grams, 20% impurity. Right away, that tells you this is 80 tons Fe2O3 is what we have. We'll give iron by reduction with H2 equal to. So Fe2O3 giving you iron, this is a simple equation. You don't even need to know this. It gives you iron, that's all. Okay, now when you look at it, the molecular mass of this is 160 grams. 160 grams gives you 2 times 56 grams iron. 160 grams. So 80 grams will give you 56 grams iron. 80 tons will give you 56 tons iron. This is the little tricky one. 2 oxides of metal combining 50% and 40% of metal respectively. If the molecular formula of the first oxide is MO2, what is the molecular formula of second oxide? It's multiple ways to solve it. Okay, logic use panni seekiram kondu varalam, or you can do systematically. Now this is in essence what is given, correct? First metal oxide 50-50, second metal oxide 40-60. Okay, all right. Now logic based answer is they have equal amount here. Equal amount. Here it is unequal. So 40 is to 60 or 4 is to 6 or 2 is to 3. We can do through equivalent weight if you want. Let's say I have it already typed here so that it's easy for you to read. First oxide metal எடுத்துக்கலாம். Weight of oxide is 100 grams எடுத்துக்கிட்டா 50 gram 50 gram. This is very simple. I've always asked you to take 100 grams. 50 grams oxygen reacts with 50 grams metal, correct? 8 grams oxygen will react with 8 gram metal. Why I am going for 8 gram? Remember, this is the equivalent weight definition that we saw when I taught you equivalent weight. How much of something will combine with 8 grams of oxygen? What is the equivalent weight of oxygen? Molecular mass or atomic mass divided by charge, O2 minus another. So 8 grams. 8 grams. So the equivalent weight of the metal is 8. Equivalent weight of metal is 8. Metal oxide formula is MO2. Atomic weight of the metal is 32. The reason? MO2 means we know that this is 4 plus. Because oxygen is 2 minus. அப்போ இது 4 plus தான் இருக்கணும். எனக்கு இப்போ equivalent weight தெரியும், charge தெரியும். Molecular weight is equivalent weight times n factor, charge 32. I know the atomic weight of the metal. Now I'm going to go to the next one. MOX. I don't know what it is. I know this is 40 grams, this is 60 grams. Okay, we cannot carry over the equivalent weight because it could be a different one. But one thing we know is this is 60 grams. 60 grams divided by 16 is moles of oxygen. What is the moles of this? 40 by 32. This is the mole ratio. Moles of M is 40 grams divided by atomic weight. Moles of oxygen is 60 grams divided by atomic weight. So we have 2 here, 20, 1 is to 3. So MO3, beta is the option. Equivalent weight is a tricky concept. If you are rusty on it, go back and look at the previous lecture of equivalent weight and come back to this one. Definition of equivalent weight, I have explained it based on oxygen, chlorine and silver. Alright, the last problem that we are going to see today is 20 grams of calcium carbonate is treated with 100 ml of so much. What is the amount of CO2 produced? So I have just listed it here, molecular masses. Okay, now I haven't done anything. Now look at it, 100 grams, or let's go here, 100 mils of 20% HCl. Roughly density 1 edutha 100 mils 20% HCl is roughly equivalent to 20 grams. Okay, so I'm taking 20 grams of this. So I'm taking 20 grams actual. 100 needs 73. Okay, it needs less than what you take. 100 க்கு 100 தேவைப்படல, கம்மியாக தான் தேவைப்படுது. Okay, அப்போ 20க்கு 20யோட கம்மியாக தான் தேவைப்படும். Correct? So this is my limiting reagent. This is my excess reagent. I don't need to know how much excess. I just know that it's not a 1:1 mass ratio. Hence I can say this is my limiting reagent. So I have told you so many times this is 100 ஞாபகம் வச்சுக்க சொல்லியிருக்கேன். Then what I know is what is the amount of CO2 produced. 100 grams gives 44 grams, 20 will give you divided by 5. That's all. So it's extremely simple. So you're going to have 8.8. Now let's even take it further. How much of HCl used up? 20 grams is how many moles? 1 by 5 moles or 0.2 moles. So when it comes to HCl, 0.2 moles is used up. Moles HCl given is 20 divided by molecular mass is 36.5. This is the moles HCl given. Moles HCl used is 0.2. Leftover is, let's call it 1 and 2. 1 minus 2. So we know the moles. Leftover mass would be times molar mass. Alright. Hope this was clear. Now go back and solve the worksheet again. If you have any other questions, let me know, guys. Thank you.